So and and or problems. Here's the formula for an or problem down at the bottom. A and B just stand for any event that's going on. You know, maybe it's rolling a 1 or rolling a 5. You know, it's like that. We just call it A and B because we don't know exactly what it's referring to. So, probability of A just means probability of the first thing happening. And then you add that, or addition problems, you add that to the probability that the second thing happens. But then you have to subtract off any time the probability of A and B happen at the same time. And we'll do examples of this. Sometimes it's impossible for two things to occur at the same time. Sometimes it isn't. So like if I said the probability of rolling a 2 or the probability of rolling an even number, those two things could happen at the same time because a 2 is also even. If I said the probability of rolling a 1 or a 5, those two things can't happen at the same time. You can't roll a 5 and a 1 at the same time. So we only subtract off when two things can happen at the exact same time. And the reason we subtract them off is because they've been added in twice. They're added in the probability of the first one and with the probability of the second one. So that's why we got to subtract one of them off. So here's an example. You can write it down. Yeah, you can see where I had to. Yeah, there's a whole long story that I won't get into. But anyways, you can just write down what you need. You don't have to write down everything here. But we have the numbers 1 through 10 on pieces of paper. So it's kind of like on that last test, we had a problem that had the numbers 0 through 9. It's the same thing. They're written on separate pieces of paper. And those 10 pieces of paper are then individually put in a hat, and one piece is randomly selected. And we're going to find the probability that that piece of paper contains an even number or a number greater than 6. So, important things to know. You have all these numbers written down. They're put in a hat, and we want the probability, basically the question. Probability that it's an even number or a number greater than 6. Or problems are super easy to figure out because they actually have the word or in them. So it's like, oh, this is an or problem. And problems, not so much. So when we get to and problems, they don't often have the word and. Sometimes they do, but not often. So a question that I'm often asked about these problems are, well, is it with replacement or without replacement? Well, we're only drawing one number. So that's why it doesn't matter. Yes, sir. What?
What is with replacement?
With replacement. Okay, sorry. I was like, what? Okay. With replacement would mean like if I was drawing two numbers, then I would reach in, pull out a 2 or whatever. I'd look at it. I'd put it back in, shake it up, and then draw a different number. So you've replaced it. Without replacement would mean you'd reach in, draw whatever, say the 2, put it off to the side. Now when you draw in, the 2 is not in there, so you have less to choose from. So it changes your probability. Good question. Make sure you guys work on this. I mean, I know it's not due yet, but it has a lot of problems that have with replacement, without replacement. So you can be sure to ask questions about those so we can do them. Okay, so this one, it doesn't matter if it's with or without replacement because you're only drawing one thing. If you're only drawing one thing, it doesn't matter if you put it back or not because you're not drawing another one. So basically what we have here is a probability that it's an even number or a number greater than 6. That's how I'm going to write it. So that's like your probability of A or B. So we're going to use that formula that we just wrote down to figure out the probability of this. So it's the probability that it's even. That's what that E stands for. Plus the probability that it's greater than 6. Then minus the probability that it's even and greater than 6, and that's at the same time. So probability that's even. So we look up here at the numbers. Even numbers are like 2, 4, 6, 8. Exactly. So we have 1, 2, 3, 4, 5. So it's 5 out of 10 are even. Now I'm not going to reduce it until the end because when you add fractions, you want to have a common denominator. So it's better to leave it alone. And then we reduce at the end. Now the probability that's greater than 6. How many numbers are greater than 6?
4.
Yeah. So yeah, we have 7, 8, 9, 10. There are 4 numbers that are greater than 6. I didn't include 6 because it said greater than. If it said greater than or equal to, then I'm going to include 6. So there's 4 out of 10 that are greater than 6. Then I subtract any numbers that are both even and greater than 6. So do we have any numbers that are both even and greater than 6? What numbers are even and greater than 6 at the same time?
8
8 and 10. 8 is an even number and it's bigger than 6. 10 is an even number and it's bigger than 6. So I subtract off 2 out of 10. Now, any questions of where I've gotten any of these numbers? Now, since they all have the same number on the bottom, that's why we didn't reduce. We just add or subtract, whatever it says, the numbers on the top. So 5 plus 4 is 9. 9 minus 2 is 7. So your answer is 7 over 10. Now it won't reduce, so we're done. So the probability that we pick a number that is even or greater than 6 is 7 out of 10. So it's a pretty good probability. More than half.